Okay, let us look at chapter 9 in your Max 2. Okay, so basically, if you look at over here, this is the summaries in your Max 2 module. Okay, as you know, there are two types of random variables. The first one is the discrete. Okay, so discrete at it is 1, 1, 1, 1, 2, 3, 4, and then continuous means is you have a range. Okay, for example, for 0 to 1, then from 1 to 2, and so on. Okay, so these two major, if you see that is you have two majors, two major random variables. One is discrete, so another one is continuous. So basically, the way to find the probability and the probability, the what is another thing called a cumulative distribution, and then the expected value and the variance all are different. Okay, because of the nature of these two two random variables. Okay, so if we look at this number 2, okay, so for a discrete random variable x, that you're going to have okay, so the probability must be okay, so satisfied for this one greater than 0, and then actually the keyword of all both random variable actually is the sum of all the probability must be equals to 1. Okay, if they are not equals to 1 means that that one is not the probability distribution. Okay, it's regardless discrete or continuous, both are the same. Okay, and then for a discrete random variable, the cumulative distribution function f, they use a capital F, is defined by, okay, so actually you just sum up all the probability, and then the end, the last column you will get is equals to 1. Okay, and then for the continuous random variable, the probability density function, okay, the small letter f must satisfy, okay, must be greater than 0. Okay, actually the probability must be equals to greater and equals to 0 for all xi, and then same as the last one, the sum of everything must be equals to 1, and then there is a key over here that is for the continuous random variable, for the px equals to x, so for is equals to 0. Okay, so it's contrary with your discrete. Actually your discrete actually is equal to 0, and then for your continuous is greater. Okay, the thing is will be fx is always is greater. Okay, and then for the cumulative, okay, since if you already say that, see that is the continuous, actually they are using the integration. Okay, so in chapter 9, basically you must know how to do simple, actually is the polynomial integration and differentiation. If you don't know these two, definitely you cannot answer for the continuous random variable. Discrete definitely no problem, because as long as you know how to multiply, then it will be okay. Okay, so for the continuous random variable, the probability lies between A and B. Okay, it's between, okay, if you see over here, because when x equals to x is equals to 0, so means that if any question asks you to find the probability x in between A and B, actually are same as you are finding A inclusive, x is inclusive A and B, they are the same because the equal are 0. Okay, so you so how to find this probability? So you means you are integrating from A to B. Okay, so maybe some of you asking, so how about if you want to find px greater than b for the same thing? So you know that is the whole thing, so you need to find y minus and so on. Okay, okay, so basically there's hardly they will ask you this thing, because it's quite sometimes it's quite difficult for you to integrate. Okay, then for a continuous, the cumulative is from negative infinity until the x. Later on, we will see that is how we're going to find the cumulative distribution for the fx. Okay, and then because of the two different the random variable, the way you find the expected value, okay, or sometimes we just use expected value, mean or average, they are the same thing. Okay, expected value, or in Malay, it means that it's jangkaan. Okay, what you jangka akan happen. So means that it's the mean. Actually, it's not the mode. Okay, the mode and the median, they have a different definition for this one. But this one mean actually is the expected value, or we can call it as an average. Okay, so for the discrete random variable, you are using x multiply single of it. If you want to find for the continuous random variable, so you integrate and same thing, you have one x over here. Okay, and for the variance, okay, for the variance, hardly people use these two definition. Most of the time, we are using variance equals to ex minus ex squared. Okay, and what is ex squared? Actually, from for the discrete means that you use the summation x squared px equals to x, and for the continuous is the same thing, negative infinity until infinity. This is x squared and then fx dx. So this one will be for the ex, and then after that, you just substitute the value inside. Okay, and then these two actually basically are for this one. Okay, so this one you need to please don't wrongly remember. Okay, for expected value, okay, or your mean, doesn't matter if you have a ax plus minus b, or you want to say b plus minus ax, they are the same thing, as long as when you take out the thing, a is taken out, okay, and ex, and plus minus b following what is the sign over here. And variance, okay, variance actually is the one with a square. So that's why, and then variance b, actually variance for a number actually is 0. So then when because of this is the coefficient, so you will having a square. Okay, so regardless this, even you have a b minus a square, and then this thing is still minus because this one is a minus a square. Okay, so this one, okay, so if you see there is variance is impossible to have a negative value, because later on you have one friends of the variance is called standard deviation. Okay, so the standard deviation is the square root of your variance. So it is impossible that your variance have a negative value. Okay, so now this one is basically is your chapter. This is chapter 9. What is the few information you should know? Okay, the most important part is everything sum up must equals to 1. That is the first important thing. And then how you want to find ex, okay, and variance. And then using this type of information, okay, so actually basically this is all you need in your chapter 9. Okay, so now let us look at few of the examples in your this book. Okay, so now, okay, one thing that is this note is not in your the back of the summary is how you get the median from a discrete random variable. So means, okay, this we know that is median is at the half. Okay, so you are calculating the sum of your probability, and see on which number, okay, on which number the 0.5 falling into. Okay, so for example over here, this question they ask you to find, okay, define the mode and the median. Okay, mode is the one repeated with the probability highest. So this one will be your mode that is straight. It's not 0.4. 0.4 is the probability. What is the numbers that happen for the most occurrence? So is the 3 is your mode. Okay, median, we know that is the total of probability is 1.0. So median means half, so it's 0.5. So you sum 0.1, 0. Plus 0.2 actually is 0.3. So 0.3 plus over here is over here. So 2 actually, so your median is fall into the number 2. Okay, so that's why you look at it, why it is said that your median is 2 and then your mode is 3. Okay, so now how you want to find the cumulative for a discrete. Okay, so because discrete must be 1, 1, 1, 1. Okay, 1%, there is no continuous. So how you want to build the table for this cumulative distribution function? Okay, so you look at the first number. Okay, the first number here is 0. So you need to put x less than 0. Okay, for discrete variable, discrete random variable, the equal sign is very sensitive because it is in bringing the meaning, not like your continuous is meaningless. Okay, so this thing happen. Okay, so when you less than 0, so means it's below here is nothing happen. And then from 0 before you reach 1, from 0 before you reach 1 is 0.1. And then 1 before you reach 2, so you sum these two. So from, okay, although you're saying that is, ma'am, this one is 1 to 2. Okay, actually it's cumulative. Okay, chonga. Okay, so means that this one actually is from the range is from here, so you are from 1 to 2, okay, but actually is from the previous people sum to you 0.3 and then keep on summing, and the last one, okay, x greater than 3, so the last one actually is 3 greater than 3 must equals to 1.0. Okay, if this one is not 1.0, so means that this one is not a one is actually is not fulfilling your random variable. Okay, and if you see that is the probability must sum up equals to 1.0, this one must be 1.0. So that is the key, that is how you want to verify, or how you want to show a thing or a table or a function is a random variable. Okay, now let us look at another one example here. Okay, so okay, so this one actually is wrong. Okay, so I don't know which one. So this one you better check on your book which one. This one is belongs this one. So find the median. Okay, so this one you no need. Okay, if you from this thing, you already no need to find where to calculate to sum up by yourself 0.5. So means that your range actually is at the what? Is 1 or 2? Actually is at 1. Okay, so now how do you know that is? Okay, how? Okay, the first one actually is they ask you to find the probability function. Okay, so you know, first thing, this one actually they didn't say what is the y, so this is a y. So probability of your y. Okay, so probability of your y. Okay, so then we see the first one actually is -1. The second one is 1. And then the last one is 2. Okay, so, and then 0.2. We know that must be 0.2. Okay, so 0.2, okay, it depends on how you want to minus out from the top, or you want to find these two difference is also can. So it's up to you. Okay, this one is quite easy. I know this one is 0.3. Actually this one is 0.5. And what is the median? So actually is 0.5, so it's at 1, it's not at 2, because when you cross over here, it's already greater than 0.5, so your median is 1. Okay, so now we look at the, okay, so mode for this question, okay, so mode for this question, please be careful. This one, what they given to you is a cumulative. You don't look at this one and then you say that this is 1. Okay, so this is 1 is wrong. Okay, so this one actually they already try to help you, the probability function of this one. So like just now, okay. Okay, so okay, then cumulative for x, y, okay, y, this one, okay. Then if you see here, you know that 5 means actually is greater than 5, okay. So if you don't understand this one, actually if you see that actually is greater than 5, so you cannot have a 5 here, actually is a 4, 3, 2, 1. Okay, so 4 actually is this one minus this one is 0.12. Okay, and then I think, okay, sorry, this one I think is until 5. Okay, so they take the first figure, so 0.12. Then 0, okay, how to 0.12, then this one, okay, so 0.15, okay, 0.0 something, 0.22. 15, so 7, 0.07, and then 0.36 minus 0.22, so 4, 0.14, and then the last one, 0.88 minus 0.36, so is 2, 8, so is 5, 0.52. Okay, so from here, you can see that the highest actually is at the 4. So 4 is your, for y equals to 4 is your mode. Okay, and then it asks for the probability 2 to 5. Okay, actually, if you want, okay, you can read from here. 2 to 5 is not inclusive 2 and it's not inclusive 5. Okay, it's quite hard to read from here. Okay, if I know some of you that you can try using 0.88 minus 0.22, that is one way. Or we no need to gamble that. Just use these two sum up is your answer. Okay, so this one is another one example. Okay. Then we look at over here. Okay, so this one actually is a continuous, okay, continuous random variable. Okay, because this one, the continuous for the density, the probability density for this one, okay, and you know that is when if you remember integration, okay, integration of a function, it means that is the area under the curve. Okay, so means the total of this one, okay, the total area of this one must equals to 1. Okay, so how you want to find it is I want to say is this is a C. So what is the area of a triangle? 1/2, base is 3 times if your C is must equals to 1. So C equals to 2/3. So then this is your C, and then compute if you want to compute Py greater than 2.5. So equal 0. Okay, greater than 2.5. Okay, this one, okay, for this question, there is no, they didn't provide you any function. Actually, it's quite simple. 2.5 is here. Okay, so 2.5. Okay, then 2.5 actually from 2.5 to here is what is the thing. Okay, now we have a problem. What is the respective over here? So this one is quite easy. Use the ratio of a triangle. Okay, because this triangle sharing over here, so this one you're using the ratio. Okay, ratio, then 2/3 ratio of the height actually is the same as 1.5. Okay, I think you need 2.5. Okay, this one from, okay, this one is 1.5, right? Okay, 1.5, sorry, 1.5 ratio the height. Okay, our height actually is just now 2.3. Then, okay, sorry. I think I missed up the thing. Okay, so my height, I want to know the height of this thing is called my height, and ratio to 2/3, okay, is equals to this length. Okay, so this length actually is 1.5/3. So you can get your h. So then from there, half multiply h multiply 1.5. That is the probability of this triangle. Okay, so this is how you want to find it. Okay, so happen to the same thing for this one. Okay, and don't get confused by this negative, because as long as you find the area, so this one is 1. Okay, this is 1. This is also 1. Okay, so means that you already know actually this is 0.5, this is 0.5. So half 1 multiplied with your c equals to 0.5. So your c actually is equals to 1. Okay, so this one, you see, while you already get this one, so how you want to find less than and so on. So basically, I'm using the same method as the previous one. Okay, so then we go for this one. Okay, after that, this one, if you see that is for the what is the thing called, for the for the continuous. Okay, the FA, actually A means is from your starting. This is your B. Okay, actually some sort like that. Okay, so the cumulative at this moment is 0, because all of them they start from 0, and the full strength of them actually is 1. And if you want to know, okay, the probability from both from A to B actually is integral A to B fx dx. At the same time, after you integrate small letter f, you will become a capital letter F, that is called cumulative, and we substitute BA, so it's the same thing as FB minus FA. So this one, please remember, especially when they provided you the cumulative distribution, because not every time you can integrate, okay, because sometimes you also don't want to integrate it. Okay, and how you want to get from cumulative back to the normal one actually is using the differentiation. And one more thing is, if the median, like just now, okay, the median just now is you, because the one how you find the cumulative is by summing up. This one is by integrating. So from negative infinity until the median, okay, for that function is equals to 0.5. So from there, you substitute inside your m, then you can find what is your m. Okay, so now this one. So if you want to find the density, or sorry, you want to find the cumulative, so you just integral from negative infinity. Okay, although it said that from negative infinity until the x, okay, but this function told you that is you only define the function fx is only defined in between -1 to 2. Others than that are 0. Okay, so means that although it's negative infinity x ft dt, so from negative infinity until -1, you are integrating towards 0. So that's why it will become until -1 until tx only. Okay, so that's why you took this one. Okay, so why suddenly from this one to this one actually is doesn't matter. Okay, so as long, and if you want, okay, actually they just try to make you don't confuse. That's why they use this one is t, so you won't confuse this one is x. Maybe some of you will be starting confused which one to use. Is already integral or not. Okay, so just change the alphabet x to become t squared, and then you substitute the x and -1 inside, so you get this one. And because you already okay, you already find the cumulative. Okay, so how you don't want to find another time, okay, because this one is the second one. You don't want to find another time by negative infinity until m ft dt equals to 0.5. Actually, you just take this one, substitute with your m's into it, into here, that equals to half is already fine. Okay, so then they ask you to compute this one to this one. I know you said that is saya boleh integrate from -1 to, sorry, 0 to 1, okay, because from this one actually is -1 to 0, and then for this one is this one. But why no people want to integrate? Because you already integrated once, okay. Once you already integrated, no point you want to integrate second times, okay? So just use back the one over here. Okay, then this one is, okay, then we look at another, okay, so this one is median. Okay, so this one, okay, now this one is after you see, okay, this one after you integrate, okay, how your density is only 1% there. Okay, then maybe you say that, okay, maybe some of the question, okay, some of the question asking, okay, find the, okay, actually find the fx. This one is not complete actually. Okay, so if you want to see the complete one, the fx actually is down here. Okay, this one actually is the complete one. Okay, so means that this one fx, you should give, okay, your answer should be fx less than, okay, -1, okay. So I think this one in between, okay. So x less than -1 is 0, and then in between -1 2 is this one, x cubed minus 1 plus 1 over 9, then x greater than 2. Okay, now sorry, yes, it's greater than 2. Okay, how do you know? Okay, because how do you know? Maybe some of the question asks you to show that this particular further is a property function. Okay, it is a density and so on. How? Okay, so then you just take this number 2, substitute over here. So 2 power of 3 is 8 plus 1 is 9. 9 over 9 actually is 1. So once you get this one is 1, you already fulfill how to show this one actually is a random variable. Okay, this you must see. So actually this one is the correct way to present your continuous cumulative distribution function. This one is the correct one. Okay, and how do you want to find back? Okay, so and then you differentiate. Okay, so differentiate. Okay, so differentiate to y. Okay, sorry, to y over 6. This one is negative, sorry, is 8, 3y squared, and so on. Okay, and the most important part actually is this range. Okay, so if you look at this answer, this is the correct way how you want to write it back is otherwise. Okay, and like I mentioned just now, no one want to, because this one, okay, this one, if you see here, the probability density come after finding the probability in between 1 and 5 over 2. You already know one thing. You no need to integrate. Okay, and then you check where is 1 and 5 over 2 you located. Okay, so 5 over 2, okay, and then by the definition just now I said that is this one is the most important part. PAB is this one. So what they do is they just take the PF 5 over 2 minus 1 and 5 over 2 from where actually 5 over 2 is located here. Okay, 5 over 2 is located here. 5 over 2 is 2.5, so it's located here. You substitute into over here, minus where the 1 from 1 come from the y square over 6, substitute 1 inside, so you get your answer. Okay, okay, so let's say, okay, and maybe some, okay, then you find the normal random variable, the small capital, sorry, the small letter y. Okay, if you want to find back the same answer of this, you need to find, okay, you need to integrate from 1 to 2, then 2 to 5 over 2 to find back the same answer for this one. Okay, so you also need to separate it. Okay, and the median, okay, median, very simple. Since this one is already sum, so you substitute the 2 inside here. 2 is, when you substitute 2 inside here, is 4 over 6. Okay, okay, when you substitute 1, okay, so it's here. Okay, so it's 1 over 3, and so then you will find where your m located, so you can find your m. Okay, so this one is your another example. Okay, for this one, okay, so this one, okay, this question is not continuous random variable. Okay, because it is impossible you have you don't have anything here. Okay, because the probability density function means that you need to differentiate, because if you differentiate 3 over 4 is 0, so 0 0 0 all are 0, it's impossible you have 1. Actually, I think this one actually should be is a discrete. Okay, so this one 15. Okay, so 15. Okay, okay, this one. Okay, so this one. Okay, example. Okay. It said that in a game, a player will be paid 6 ringgit if all the heads or the tails appear. When 3 fair coins are tossed together, the player will have to pay and so on. Okay, so now if you see their solution, okay, the solution is like this. Okay, it's very descriptive. Okay, it's very descriptive with all the ayat and so on. Actually, no need. Okay, so what you need to do is, okay, you can just let them is the sample space of this one, because you want to know how many, what is the occurrence. Okay, so if over here we know that the all head or tail, the total of numbers, okay, numbers of sample actually is 8, and 2 happen actually is 2 over 8. So others than that actually is 6 over 8, because their sum must be equals to 1. Okay, and why this one is a 6 over here, why is not 3 head 3 tail? Because when you have the 3 head and 3 tail, you will get 6 ringgit, and if you lose, then you will lose 3 ringgit. And then how to find the, this one is a discrete because it's occurrence 1 1. Okay, didn't continuously happen. So how to find the expectation for the discrete? Just use the x multiplied with the probability 6 times 6 times 2 2 over 8 plus negative 3 multiplied by 6 over 8, so it's this one. So actually this one, no. Okay, actually you will be wondering why, and this one actually if you can form this one is fine enough. Okay, so then this one is 9.12. Okay, and then this one, okay, I know that is actually is a bit confusing. Okay, because after happen this example, okay, after happen this example, and they have this example, why make losing as the negative 1? Actually their mindset is, okay, this one is on the player side, expected gain for a player. This one actually they are asking, is it this game fair or not? Okay, so that's why. And then this one actually this is a calculation error, so their the way is not going to affect anything. Okay, so this one is 16. Okay, and then Okay, and then actually you're going to have the similar question for this one. You can try. Okay, it's a similar as this one. Actually, when they are saying is it actually is the second example, not the first example. Okay, and then 25. Okay, let me check. Okay, okay, now this one. Okay, this example, okay, one thing that, okay, this example, what I want to tell you that is, if not mistaken, okay, oh, okay, there's one thing is, I think I want is one of the example, okay, I've forgotten is which example, I think it's, no, I think I've forgotten is which example, which is not a cumulative, is not a proper density function, because the sum, you cannot get the sum at all. Okay, the sum is not equals to 1. So that's why not every time you go and try, okay, you go and try for this type of random thing, not necessarily you will get equals to 1. I think unless the question asks you to calculate, if not, then you better don't try, okay? Because it will be, because just now I did try some of, there is one question which I cannot get 1, okay? I think it's this one, okay, it doesn't matter. So now, from this probability, okay, they ask you to compute EY and then variance, okay. So, as I say, EY, they said actually is from negative infinity, okay, and negative infinity until infinity, x, fx, dx. Okay, so that negative infinity until 0 is 0. So now that's why we hardly write, we only write 0 to 1. Okay, since this is y, so it's a y square dy plus, then from 1 to 2, then multiply y, 2 minus y, please expand it, dy. And for variance, nobody want to use the other formula, just use ey square. Okay, so then instead of x is become 0, 1, y cube. Then this one will become y square, 2 minus y dy. So 1, and then your variance is y square minus y. Okay, and your variance never ever negative. It can be 0, but cannot be negative. Okay, and one thing, if you see your variance are taking the answer from EY, please make sure you calculate it correctly. Okay, but once you get here is negative, you already know that you are wrong. Okay, so this one is example. Okay, after that, okay, so now we look at your exam questions. Okay, so the first question is this one. Okay, so in an automotive service station, 25% are tuned up, are done on the 4-cylinder automotive, and 40% 6-cylinder, and 35% on 8-cylinder. Let X be the number. Okay, so they already say X be the number of cylinders. So 4, 6, 8. And change it to become 0.25, because this one is a probability. And now Px equals to X. Please label it. And the sum of them, 6.5 plus 0.35 is 1. So this one is valid. Okay, so this one is the probability of the function. And the cumulative, so I say, okay, so cumulative, we have the f, x. So start from 0, then x less than 4, then 4 in between of our 6, so is 0.25, and then 6 in between 8 is 0.65, and then 1 greater than 8. And then how to draw the graph, you can see at your the previous one. Okay, and then over here, okay, this one actually have an equal sign. And insurance company offer its policyholder, this one T, the number of months being successful payment, and the cumulative distribution is this one. Fine. Okay, so first thing, If you want, you can build back the table. Okay, for me, building table is easier. Okay, so greater than 10. So that means the last number is 10, then 6, 5, 2. Okay, so the last one, the difference is 0.25, then 0.25, then 0.3, 0.2. Then this one is your, they call it as well. They say T. So this one is, okay, actually it's a small letter T, P, T, T. Okay, so this one. And please don't use X because the question say it's a T, so you must use back the T. Then expectation, so just use this multiply. Okay, so multiply, then you already can get the answer. So, okay, that is the easiest one. Okay, so then this one, then here have not. Okay, so this one actually are the similar question. The median, if you see over here, 0.5, so the median actually is at the 5. Okay, so this one 0.5 is 4 at here, so your median is 4. Okay, so now, okay, so we look at this one. Okay, the probability of this one, find the value of P and the Q. Okay, so EZ equals to 29. Okay, so now, okay, first thing we know that is sum everything up equals to 1. That is the first thing. But you have 1 plus 1 over 3 plus 1 over 4 plus P plus Q equals to 1. This is your first equation. Then second equation, this one, multiply, 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 multiply. Sum is equals to 29 over 12. Then you will get the second equation. Okay, then how to find E for Z? Okay, this one is the easiest. Okay, by definition, for E, Z minus 1. So EZ is already here. Don't calculate again. Okay, maybe you will calculate wrongly. Just use the one they're given to you. So for 29 over 12 minus 1. Variance. So variance of, okay, this is variance Z. Okay, so suddenly I thought it's E for Z. No, actually it's variance Z. So you need to find EZ square. So square, 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 multiply. Okay, if you want, you just square here 1, 4, 9, 16, 1 times 3, this one sum. Okay, so settle your EZ square. Okay, one thing, please always show, okay, please always show what is your EZ square. Then you use your EZ square to minus the EZ, then you get your values. Okay, practice a good practice. Okay, and this one, they ask you is a continuous random variable. They ask you show the function is a probability tension function. So you just integrate 1 to 3. Okay, you integrate 1 to 3. So it's a 1 over 6, y plus 1, y. So you're going to have your y square plus, okay, sorry, is 1, 2x. Sorry, this one should be 1, 2x. Okay, so they just now they use the t, right? Okay, t, t. So this is y. So actually will become t square plus 1. Substitute. This is 1 over 6. Y1. So you can have a 1 over 6. Y t square over 2. So y square over 2 plus y minus 1 over 2 minus 1. Okay, then, okay, so actually this one is for the density, and what you need to do is just substitute the 3 inside. It must give you 1. Okay, so that is how you find your density. Okay, if not, then simple, just integrate until 3. So from 1 to 3 must give you 1. So then is how you want to show. Okay, this one is a continuous. Okay, and then find 2 to 5. So 2.5 is here. So you just integrate from 2.5 until 3. Then you already can get the probability. Then expected value variance is just like the previous one. Okay, so 22. Okay, this one. 5 cumulative. Okay, so this one. Okay, so this one, these two. Okay. Oh, I know why I choose. I suddenly I forgot. Okay, why I choose this one. Okay. Okay, so this one actually I took from here, the cumulative distribution FW, okay, because in your book, okay, in your book, majority of it, they show, okay, what they show actually is only for the one, okay, if you've noticed, most of your function, in the example, what they show is only one function, then the second one is always otherwise. This one have a two function here, then the third is otherwise. Okay, so how you want to find the f? Okay, so for the in between, okay, we know that when x less than when x less than 0, your fx is 0. That is a must already. Okay, so just like this. Okay, and then for the range of 0 until 2, we know that we are, okay, following the definition is our fx actually is integrating, okay, integrating from 0 to x, okay, 0 to x, and then took this particular, this one, the first one is 1 over 4 dt. Okay, since the question just now they use t, so we're going to have 1 over 4 t x 0. So actually it's 1 over 4 x. That is for the 0 to 2. And then from 2 to 3, we have our fx integrating, okay, because actually this one is a cumulative, okay, so we don't want to, because this function, okay, is only for 2 to 3. How about the person before? So what you need to do is took, okay, so means you count over here, you calculate, okay, over here you calculate f2. Okay, how this f2 coming from? The last number of this one, you substitute inside here, so mean it's 1 over 4, 2 actually is 1 over 2. So you sum 1 over 2, put 1 over 2 here, plus integrating from 0 to x, this is 2 to x. This one is 2 to x. Take this one, I put 1 over 4 outside, okay, 2x minus 3, 2t, okay, 2t dt. Okay, then now is equals 1 over 2 plus 1 over 4, 2t squared over 2 minus disappear, 3t, substitute x2. So 1 over 2 plus 1 over 4, substitute x squared minus 3x. Okay, then minus, okay, minus 4, minus 4, this one is minus 6. So finally, we have 1 over 2 plus 1 over 4 x squared minus 3x. This one is minus 2 is plus 2. Okay, so you have this particular, okay, you sum up later. Okay, now how do you know that this one is correct or not? Okay, so what you do is when x greater and equals to 3, okay, our fx must be equals to 1. Okay, so when it must be equals to 1, so what we do is we took this number at the last, substitute inside here. So 1 over, actually it is 2 half, so it's 5 over 2 plus 1 over 4. Okay, so put the 2 inside. Where is my 2? Where is my, I substitute 3 inside. 9 minus, 9 minus 9. Okay, correct, right? 9 minus 9. So equals to 0. So actually, that is the reason you see they didn't ask you to calculate the density. They didn't ask you to find the cumulative distribution function because, okay, later on you verify where I do the error over here because it should be equals to 1. If not, then this one is not a density It's not a density function. Okay, it's not a probability density function. Okay, so this one, okay, so it's the same thing. Okay, so this one just now I tried this one is possible. Okay, so what you need to do is just like just now. Okay, so integrate from 0 to x for w d sorry, this one I should put w, cannot put. Okay, and then t dt. So you have a t squared over 2, then w0. So this is your w squared over 2. Okay, this one is w squared over 2. And then the next one, same thing. You need to substitute 1 inside here. So you are, for this one will become p. Okay, your f, okay, your fx will become half. Where this half coming from, substitute 1 inside, actually is 1 over 2. Then plus integration from 1 to w, okay, 1 to w, and then 1 over 4 dt. Okay, so this one actually is 1 over 4 plus t squared over 8. Okay, substitute w and 1. Okay, so finally you have 1 over 2 plus w squared over 8, then plus 1 over 8. Okay, then now how you want to show this one is dense, and then what is the next one? Fx. So substitute 3 inside here. Okay, substitute 3 inside here. So you will have 1 over 2. Okay, sorry, this one actually is a minus. Okay, minus. Okay, so 1 over 2 minus 1 over 8 plus 3 over 2, actually, so 3 over 2 is 9 over 8. Okay, why I have still have 1 over 2. Okay, so okay, then you calculate back. Okay, so this is how you want to find your cumulative distribution. What happened to me? Okay, t square. Why I have a t square? Actually, it's a t. Okay, sorry. Okay, don't scream at me. Okay, 1 over 40t, actually this one. Okay, this one, sorry. Okay, this is called I don't have enough space. Okay, so when you do, don't squeeze everything in one thing. Okay, so to tally this one actually is your FW should be, okay, sum the 1 over 2 from top, integrating from 1 to w. Take this function is 1 over 4 dt. So 1 over 2 plus 1 over 4 t, w and 1. Okay, so 1 over 2 plus w over 4 minus 1 over 4. Okay, so actually this one is finally w over 4 minus plus 1 over 4. Okay, so then what you need to do is, if you want to find the last one, substitute the last number here, 3, okay, into here. So 3 over 4 plus 1 over 4 is 1. So then this is the correct cumulative distribution function, must equals to 1. And because of this is equals to 1, so you will know that this one actually is a probability of a density function. Okay, and then you can find your half. Okay, since you already find all the distribution, half is from the first one, so is you substitute half inside here, and then 2 inside the second one here. Okay, then you minus, then expectation and variable. Okay, so I think this all I going to share with you all for the chapter 9.